Hey, so 2:50 in the afternoon. I know that the food truck food is sitting, and all right. So I'm gonna try and keep this exciting for you. I entitled this GenZeal, and for a very specific reason. When you look at how people like to categorize our children, they what do they call it? The I generation, the selfie generation, as if there's this negative stereotype of the generation that's coming up. And so I want to twist it around and push and say, you know what, when you look at the children, especially today, that have been presenting, they truly represent a zeal for making change in their world and making a change in their community. So that's one of the reasons why I chose that title. My name is Laura Jacob. Just to tell you a little bit about myself. I'm very, very passionate about education. I am very new to Python and to programming. This is my first experience here at Python USA, and I was so lucky to meet some great people at PyCon UK last October, and that was my very first experience, and I felt so welcomed, and just jumped right into a new community. So it's been wonderful. So in the past, as far as education, I started off as a secondary English teacher, and that was my passion. But quite honestly, I didn't care what I had to teach. I was just excited to be there and be in the classroom and work with children. I also served as a technology coach and an elementary principal, a middle school principal, an assistant superintendent, and currently I'm in Maryland serving as a supervisor of K through 12 technology. So a little bit about our program. I am very luckily on the Eastern Shore, so less than an hour from any beach, whether I want to be on the bay or want to be on the ocean, in Maryland, in the state of Maryland, but yet just about an hour and a half away from DC or Baltimore. So you have the best of both worlds. You have great cities and great resources there, but then if you want to kick back and put your toes in the sand, you can still do that as well. In our school district, we serve just under 2,000 children, very, very rural area. So you have no chance after 9 o'clock of getting any fast food whatsoever. It's not going to happen. So we're very rural, a lot of agriculture. We're 69 in our student population is 69% white, 28% African American, 3% Asian or Native American. And our children are 60% low income. In our school district. So with this program, what we wanted to start is we wanted to start an after-school program. It's focusing at the middle level, so middle school ages 6 through 8. And we wanted to tier and teach computational thinking and programming through a tiered skill development approach, looking at both physical computing, app development, and business and community projects. So that's the whole framework for it. Now, and I was so excited when you guys brought this up this morning. The three main components in the philosophy of how I'm approaching this after-school program, as well as how we've reworked our K through 12 computer curriculum, goes under three areas. First one, Mitch Resnick's lifelong kindergarten. Even as a senior English teacher, when I picked up this book, it truly changed how I approached the resources that I chose for children, as well as how I approached education. You guys spoke with that perfectly this morning. So he really talks about taking those, not necessarily looking at the 4 C's, but he challenges, look at the 4 P's. Look at the projects, look at developing that passion and keeping that passion alive, allowing children to work with their peers and encourage them to just play. They are children, and sometimes, especially in the United States, we test them like crazy and we don't give them an opportunity to be children and to play and learn through play. Second main one, which is a big philosophy of mine, is the just-in-case curriculum versus the right-now curriculum. And what I mean by that is in some curricula and some courses, not all, and I'm going to speak from the United States just from experience, we do a lot of just-in-case curriculum. Just in case you need calculus, I'm going to teach you calculus. just in case you need to recite the Gettysburg Address, you have to memorize the Gettysburg Address, right? So we developed this whole, we have children go through these programs of just in case, as opposed to developing a right now curriculum. And one of the things that really stuck out with me was Josh. When I first met him last fall, in his talk, at the very beginning of his talk, he said, "My school gets in the way of my education." That hurt as an educator. That hurt so bad. And it made me think about, how are we approaching our child's education? We want to get to the point where it's right now. Josh is so passionate in what he's doing. We should be feeding that like crazy and keeping that going, not making his schooling a hindrance on where he wants to go. And I think that if we continue keeping that focus of right now, Josh is passionate about this and wants to learn these skills. If we keep that, we're going to retain our children in school. We're going to retain those interests that we have and help build them. And they're going to be quality individuals in our systems. And so this is an area that you're going to see how we approach our after-school program of, we don't want the just in case. And sometimes, even in tech, we're developing a just in case. In K-12, what did they start doing? Everybody buys a 3D printer, and okay, everybody has to learn a 3D printer right now, just in case you need to do any 3D printing in the world. And I think that there are times when you need to learn how to use those skills and 3D modeling skills and use a 3D printer, and that's why makerspaces do so well, because they follow that right now curriculum. Right now, I want to learn how to solder, and I'm going to take a course and I'm going to do it at a makerspace. And then I want to learn how to do a CNC milling machine. That's why makerspaces are so successful, and why our kids love them, is because it's a right now curriculum as opposed to a just in case curriculum. And then the last big philosophy is global impact. And this comes from Hale and Fisher. It's a curriculum book. It's 2013, so it's a little old, but it's called Upgrade Your Curriculum. Super easy read. You could do it in about 2 hours. But Hale and Fisher talk about making a global impact. And Josh is an excellent example of that. It's serving locally or making a change locally that can also have a global impact on the world. And so you see Josh and his work that he did. He saw a challenge. He saw something that he wanted to improve on. And little did he know, Josh, 75 countries, did you say? How many? 72 countries now. So Josh is acting locally, yet making a true global impact across the world. So I'll focus on those 3 areas as we go through. So the first one being global impact. So our after-school program with our students started off, I didn't teach them anything in particular. We started off by reaching out to businesses in our local community, and we said that we're starting an after-school program, and we want to help meet a need that you have and develop technology or equipment for you. And the kids went and interviewed different members in the community, and I want to give you some examples of what they did. So the first thing that they did is they went to a local arts community. And the local arts center gentleman, John, they interviewed him, and he said, you know what would really help is that I would really like to have a collaborative app that all the arts educators and all the art businesses and those that are in the arts community could all collaborate together on. And he gave them that challenge, and then they go after school and they start working on developing that app, which I'll show you some of their, we're still in prototype stage, but I'll show you what they have. Another one was we have a educational foundation that focuses a lot on the local resources on the Chesapeake Bay, the different fish, turtles, and various things. And the Education Foundation, when they went there, they interviewed them and said, you know, what can we do? What can we develop to help make your lives better? They said, you know what? We'd really like to have a way to take attendance of how many people come through our doors every single day because it helps us with writing grants. No problem at all. The kids said, oh yeah, we can handle that. We know how to do a simple button, and we're going to jazz it up and make it specifically for that educational foundation. But one of the great twists that they added to this is if it requires electricity, it has to be a renewable source because their building had specific codes where they had to follow, and it had to be, I think it's like 90% renewable sources. So they added a great caveat to the challenge of not only did they want a simple system of recording how many people were in attendance at their events, but it also had to run on some sort of renewable energy source. They went to the town hall, and the gentleman at the town hall explained what he does and his work that he does. And he had something very simple. He said, I just want to know in my attic and in my basement in town hall, I just want to know when the temperature is over or under a certain temperature. Very simple thing. And he said, I just want a text message to do that. So when the kids took those notes and got that information and we came back, we got out some Raspberry Pis. They learned some basic Python. We added Twilio to it, and we did that whole right now curriculum where, okay, this is his challenge, this is his specific need, and how do we make that happen? And then also with our county government, they are installing an entire new fiber optic line. And in some of the places, the plug-in places, they have little doors. They're probably about that big, maybe 2x2 or 3x3 simple doors for the fiber optics. But they're going into places like Humane Society. They're going into state's attorney's office and different places. And our government employees want to be notified if those doors are ever opened. And they just wanted a simple email. Well, again, that was a great problem for the kids to tackle, so they just went on Adafruit, found that they could get a simple door sensor, magnetic sensor, open that up. We tied it to a Pi Zero W, and they learned email notification at the same time. But again, I didn't start the planning as far as the lessons. They got the challenge first, they got the problem first, and then they had to go through all the research. Well, what do we need? How much is it going to cost? And what do we need to learn in order to make that happen? Was that comfortable for me? Not at all. Not as an educator. I want to walk in, especially with a room full of middle schoolers, I want to walk in with a game plan to tackle it. But I had to step back and go with what a lot of what Mitch Resnick says and really hold back and say, okay, let's have the kids drive our decision making and our planning. And then another one they did, this is one of our town mayors. He's also one of our employees at the school district, so that was really beneficial to be able to have him right there. But the kids interviewed him. We have a simple tram system, like it's just a Jeep and a little cart at the end that you can jump on and off the tram during the summertime. And he just wanted an app where you could follow the tram and see where the tram is, so that if you're waiting for the tram, you can get on and off the tram. It was a great way to dive into GPS and talk about GPS and, well, how are we going to power this? If this is going to be in the Jeep, how are we going to power this system? So it was a great way to build those challenges and questions with kids. So that jumps us right into that just-in-case curriculum versus right-now curriculum. So they learned that in order to have these sensors work and work permanently, you can't just keep using jumper wires. They started off with jumper wires, but they learned, hey, I actually have to learn how to solder. So we made sure that they had access to soldering equipment, and when it was time for them to learn how to solder, and they said that that need was there, then that's where I taught them how to solder. They did for the Sultana, for that place that needed a button, they did a turtle because Maryland really, we have a lot of turtles. They like highlighting the turtles. So the kids said, "Oh, we can code a simple button. That's not bad at all. But let's make it look like a turtle." So they were really excited, and so they learned then how do we develop a model and first prototype our little 3D turtle. And so they did a really small one, got it exactly how they wanted it, and then expanded it and developed it with a nice one of those big arcade buttons, so like the whack-a-mole kind of button, that's what they wanted. And but they started to dive into design, and then we got to talk about design. Well, how many toes you're going to have on your turtle, and what's we're going to add paint to it. How do we when we print it out, do we just print it and then just paint it? Nope, we need to sand it, we need to prime it, and make sure that we choose the right paint to it. So it really brought in that whole element of just tying in the different disciplines together, as opposed to teaching children in segments. This is an example of just them working on just basic prototyping. You can see that the magnetic sensors there, they dove into the magnetic sensors for the doors. And then this was their first prototype with the app. So they're working on developing an app. And what was great is that, yes, he wanted this app with 4 different categories, but then, they open up Xcode, for example, and they're like, well, what do we do now? I said, well, what's your app going to look like? Well, we just need to put in these colors. I said, okay, so what do you need to do? Oh, well, we need to create something in Photoshop, and it needs to have a certain color scheme. And we really got to dive into, well, what are your icons going to look like? What's your main icon going to look like? And we got to dive into exactly how is that app developed, as opposed to just writing it on, say, a sheet of paper or drafting something up. So they really got to go from complete scratch and start to develop their app. This is another example. In this one, they were getting started. In this one, they are, see, Nick, I even have that coding with me right there, buddy. You can see it on my notes. So they're developing a fan that'll turn on and off in one of the industrial spaces in our area. And what's great about this one is they added the element of, well, I want you to be able to turn this fan on and off, but you do not have access to our Wi-Fi. And I was so excited because they said, for privacy reasons, we don't want to have it, Wi-Fi compatible. And it was great because then I said, okay, well, what microcontroller are you going to choose? If you don't need Wi-Fi, why buy a microcontroller that has Wi-Fi on it? And so we got to really have a great, rich conversation on what are we going to purchase and why. And then just lifelong kindergarten, you guys touched on it, and I can't agree more. And if you get an opportunity to go through that MOOC, it is a great MOOC, and you can really get the voice of Mitch Resnick through his videos. We then took a step back, and as we're developing this, and this was a year-long process where the children are working on these, we took a step back and looked at the vertical articulation of how are we teaching our children to get them ready for those high school AP computer science, engineering, and networking courses. And we weren't doing a good enough job. It was hit or miss. I can tell you that in the state of Maryland, how many teachers do you think last year we certified for computer science in the state of Maryland? In the entire state? One. We don't even have approved standards yet. We're working on developing those standards, but we don't even have them yet. I was also in Pennsylvania previously. How many do we have? 0. We don't have a system yet for approving teachers to teach computer science. So when you look at this, now I'm working with our media specialists and saying, this is how we're going to develop that vertical articulation, because like the young lady said in the last session, there's no way you're going to reel them in if you just have them start in computer science in high school. There's no way. And we do them a very, very large disservice, I think. So now, keep in mind, although I have, specific programs here in the vertical articulation, it is based on those 4 Ps of peers, projects, purpose, and play. But we start off in kindergarten with Scratch Junior. Just with the iPads, we're very lucky. We are 1-to-1, so we have 1 device for every child. But we start off with Scratch Junior, basic inputs and outputs, and basic development. Around 1st grade, if they're ready for it, they go right into Scratch. They're definitely grades 2 and 3, definitely working specifically within Scratch. We do some Arduino and Makey projects with them. But around grade 3, some still need a little bit more time on Scratch to get those basic concepts, but many of our children are ready to start diving into basic Python programming. And I use Josh's resources for all of that because the children are ready for it. And what's great is that there are some teachers that say they're not ready. They are totally ready. At this age, they are eating up every little bit of information they can get from you. And if you keep pushing them and say, hey, this is going to be a challenge, but you're going to love it, and I'm going to be so proud of you if you can do it, they rise to that occasion. Children will always meet us where we expect them. I truly feel it's we as educators are the ones that sometimes hold them back. I do genuinely feel that. And so grade 3, simple circuits, 3D modeling, and then 4 through 8, a lot more Python, C, HTML, and Java, physical computing, graphic design, and web design. Some of this is because of the skill set of the media specialist that I have in that grade. So I have to, if I have that skill set there, then I want to rely on that skill set for the children. And then into high school, we offer game development courses, obviously the AP, and then there's some options where they can go into kind of a pre-engineering track, networking, and then robotics. But this is just a physical chart. I have the entire K through 8 curriculum for you in that folder if you want that, and I can also tweet it out as well. And that's all I have. We made it, right? Okay. Any questions? Okay, we have 7 minutes. Go for it.
You did mention C++.
Yes.
What's your experience with that for, I think you said 3rd grade to 4th and 5th?
It's based on, it depends on the project that they're doing. So I just put that in there because depending on the project that the child wants to do can determine which language they're going to go with it. So that's where we get. And it's basic, it's not super complex, but we want them to see, just like we want them to know different languages such as German, Spanish, and French. We also want them to know that there are different languages out there when it comes, with computer science. And so we're just touching so that they can start seeing some nuances and differences between those. Does that make sense? Okay. Yeah. Yes, sir. So, yeah, I steal a lot from the UK because they're rocking and rolling. So I know I do. Yeah, they're doing tremendous things, and I love staying on their forums and seeing what they're doing because I feel like we're not even preparing teachers yet. We're just getting our standards approved right now, and in the state of Maryland, and so we don't even have a formal process for teachers. But yeah, I do steal a lot from other countries because they're doing great things. Yes, ma'am. Yeah, we have a formal observation process. We have a model, and you can identify quality teaching when you walk in that classroom and you see who's serving as that true facilitator of the learning versus what words are the children saying in that classroom when that's happening, that can really tell you quite a bit as far as whether or not they're learning. If they say, well, what do I go ahead?
Are you doing anything? I guess my question is more like, are you doing anything differently with these courses versus
No, I can't contractually. I can't contractually based on the MOU of the union. So it has to be consistent whether you're AP Bio or kindergarten. It's the same evaluation system. So, yes, Nick.
Who's delivering this? You said you had one.
So I do the after school clubs with all the kids, but our media specialists are the ones delivering it. And that's a challenge, but they're definitely rising to the occasion, and we work very closely together. So once a month we have early dismissal time, and so I'll work with them, and we'll tinker and we'll practice certain things as they have questions. So that's how we do the.
Is there some mileage in maybe co-clubs? Where you get a local specialist, a parent who's a computery person,
Right.
and the teacher, so you've got.
Yes, that would be ideal.
It's just I've seen that in the UK and it works amazing.
I agree with you. They're working during the day though,
Yeah.
and so I think, and that's sometimes our challenge. But after school, yes, we've been really lucky that we get to Skype or FaceTime with people with professionals and to help the kids out as well as myself because I'm learning right along with them. Yeah. Yes, ma'am. Yeah. Well, I don't have it all figured out. It is a mix of ages. So the after school club, 6 through 8. Yeah, and some have violin lessons, so they're not there on Tuesdays, but they're there on Thursdays. But what the kids do is we go through that engineering and design process, and so they map that out just on simple, large Post-it paper, and we maintain that, and they keep that record so that they keep a nice. I wish I did. I don't have a formalized learning log like you guys presented this morning, but that's something I could go into. But they just keep a record of what they're doing and where they're going with it on the large sheet of paper, and then that paper comes out the next session. And whatever students are there, we just open it up. If you want to work on this task, we have soldering over here. We have 3D modeling that we have to tackle over here for this project. So here's all of our jobs, so to speak, or projects that we're working on. And then the kids just self-select. At first, I put them in different groups, and that wasn't nearly as successful as just letting them self-select. And then they go to the different groups and tackle it in the time that they have allotted. And sometimes it's just research. They're researching certain things as well. Okay, is that it? All right, thank you very much.